Good morning or welcome. My name is Wolfgang Bock. I'm coming from the company Fuchs Lubricants, Germany, and I want to have a talk about refrigeration oils. I'm since 34 years in the company, and I'm really appreciate that you will participate, and I will show you some information about propane or natural refrigerants and the influence of the oil on lifetime, on lubricity, and on efficiency. Yeah, I'm coming from Fuchs. Our headquarters is in Mannheim. We are globally, but the German subsidiary and the headquarters and the R&D and production is in Mannheim. We have approximately 1,400 employees. We are listed in the German stock exchange, MDAX, and have a look on the data, on the financial data. So we are a well-known lubricating company, and we think about that we are well-known specialists in solving problems by lubricating systems. Yeah, my responsibility and my team, we call it industrial oils. We are taking care for hydraulic gear oils, refrigeration oils, compressor and turbine oils. We call it the industrial lubricant side on a global scale. So our subsidiaries are located in China, US, Australia, Africa, and Southeast Asia as well. But the main activities with regard to R&D work is related to the German subsidiary in Mannheim, Germany. So we had a long history, and you can see it here. These are old packages where Fuchs is starting to sell. In approximately 1952, we are starting in the refrigeration business at that time with chlorinated refrigerants. So we are using naphthenic oils. After that, the chlorinated phased out was 30 years ago approximately, then introducing the fluorinated refrigerants and introducing polyol ester as an example, as a lubricating oils. Nowadays we are facing another change in the refrigerant, so we are looking for natural refrigerant, more and more CO2, ammonia, but also with hydrocarbons. Yes, here you can see it, chlorine-free refrigerant, non-ODP refrigerant. Nowadays, the focus is on the HFO refrigerants, which are still using polyol ester-based refrigeration oils, and here the natural refrigerants like ammonia, like propane, which is used especially in heat pumps system, but also in industrial system as well. It's more and more popular. So refrigeration oils should lubricate the compressor, but should also be compatible with the different refrigerant, should return from the cold side back to the compressor, should be stable, chemical stable, and should be on the highest performance level of lubricating systems. So Reniso, this is our brand. Reniso as a market leader for high performance refrigeration oils in different systems with natural refrigerants. Here you can see what does it mean. Highest performance. Here you can see that for different refrigeration systems, we are using polyol ester-based lubricants, so-called neopentyl, dipenta or monopenta, erythriol ester, which are of highest purity, of highest performance, of highest thermal stability, which are in general used for fluorinated refrigerants, but as well for CO2 as a refrigerant. Then we have the polyalkylene glycol, PHE oils, which are called, and this is a type of lubricant which is suitable and recommended for the use with hydrocarbon refrigerant. I come later to that. And for ammonia systems, PAO, so-called polyalpha-olefin refrigerant, which have the highest stability and flowability under ammonia atmosphere. Coming back to the properties of a refrigeration oil. A refrigeration oil should be miscible with a refrigerant in use. Miscible, especially on the cold side, and so we check the miscibility under the influence of refrigerant here in the miscibility gap on the left hand, under different temperature and different ratios of oil and refrigerant. In general, the system, oil and refrigerant, should be flowable, especially under evaporating temperature conditions. This guarantees oil return from the cold side back to the compressor. Chemical stability. Oil should be stable under the influence of refrigerant, under the influence of humidity and moisture, under the influence of metals, copper, iron, or aluminium. This was done in an ASHRAE sealed tube test in general. So the oil should not increase. The total acid number should be stable, should not attack the metals in this system. The test was done at 175 degrees Celsius, so at a high temperature level. This is also an important tool of chemical stability and of performance of the lubricant. Then PVE, the pressure viscosity temperature diagram, so-called Daniel plot. Solubility of refrigerants and oil can be measured under different pressure and under different temperature conditions. Here you see the vapor pressure, the different pressure conditions, here the temperature, and under these conditions at 15 bar, you have 5% dissolved CO2 in the oil, and this dissolved CO2 will decrease the oil viscosity, the thickness of the oil, from 100 down to 24 centistokes kinematic viscosity. So here you can check if the solubility of the refrigerant in the oil is too much, or if it is okay to lube the system, especially the bearing, the pistons, or the screws, whatever. This is used to check the lubricity characteristic of an oil under the influence of refrigerant. So now we are coming to the hydrocarbons. Hydrocarbons, here you can see that we have checked different base oils. Here mineral oils, polyalpha-olefin, polyolester, and PHE oils under 5 bars and 40 degrees with propan. And the lower the concentration, the higher will be the thickness of the oil. Yeah. Otherwise, if you have too much propan dissolved, the oil viscosity goes down and you go in mixed friction condition. That's why the PHE, in general, polyalkylene glycols, offer the best solubility, offer the lowest solubility of propan in the oil, guarantees the highest thickness, the best lubricity in combination with additives. So that's why we selected special defined polyalkylated glycol type synthetic refrigeration oils for propan applications. We have different viscosities. The lowest viscosity is 68, and then the higher viscosity for higher pressures and for screw applications. For screw applications in general, you are using higher viscosities. For scroll or piston applications, you are using more or less lower viscosities. Selected polyalkylene glycols with additives, especially with anti-wear and extreme pressure additives, to avoid mixed friction condition, to avoid wear under the different application conditions, different pressures, different solubility. That means if the viscosity of the oil propan mixture goes down, the additives in the oil will guarantee wear protection of the compressor, especially compressor side is important. Here you can see for the special polyglycans the miscibility behavior. Here is the concentration of oil and propan in different concentration steps. Here the temperature. Under evaporating conditions, the system of these oils and propans are fully miscible. That means the oil return even under low temperature is guaranteed because the solubility of oil in refrigerant is guaranteed with this special type of fluids. Then foaming, a conventional PHE, a conventional polyglycol, here you can see it generate under different pressure conditions, so high and low pressure conditions, generate foam, and foam will destroy lubrication films. Foam is the enemy of lubricity. That's why we incorporated here also additives to generate low foaming, low dissolving of gas bubbles from the fluid phase. And this is especially if you have different working conditions, different pressures, of very important property of our solution with propan. Because propan has a high solubility in general. Propan has a low density in general. So the creation of foam and bubbles and air, which in this case gas, which coming out of the fluid phase, is often a problem in operating for the compressor. Now here you can see also the solubility behavior. Here is the pressure, the different temperature, and here you can see under 40 degrees Celsius and 6 bar that there is 10% propan dissolved, which dilute the 100% oil to a mixture of 90% oil and 10% dissolved to a viscosity of 20 centistokes. And as a rule of thumb, oil, gas, refrigerant mixture should have 15 to 20 centistokes in under operating condition to guarantee a stable lubrication film. So here you can see the influence of different polyglycol structure with regard to miscibility. Here's the miscibility gap, the different temperature, and here's the oil ratio. And here you can see low viscosity, higher viscosity, and the highest viscosity, and the influence of the chemical structure of the polyglycol type and the thickness of the oil. The thicker the oil, the more will be the phase separation. Here you can see that here you have the phase separation of oil and refrigerant, in this case propan, a big influence. The higher the thickness, the more the critical will be the transportation behavior of the oil at a low temperature in the evaporator. So here you can see that we achieve also with the PHE 150 a very good miscibility in the fluid phase, in the evaporator, which is good for the oil return. This fluid will have some problems with oil return at low temperatures in the evaporator. So here you can see that the influence of viscosity and chemical structure has a big influence to the miscibility gap of the system. Then we are coming to a high temperature application, high temperature heat pumps or organic ranking cycles. Organic ranking cycles and high temperature heat pumps will have a problem of high temperature. High temperature will decrease the viscosity of the lubricating oil. In addition, the solubility of the refrigerant. And here you can see that isobutane or butane or isopentan or cyclopentan, which are in general in use for these applications for ORC systems, these have big effects in diluting, big effects in reducing the viscosity of the oil in the compressor. That's why we have developed 3 types of lubricants for this type of application. We have a PAG, polyalkylene glycol 460, for high temperature heat pump application in screw and piston compressors. For isobutane, for butane, we have developed a polyol ester, a 320 centistokes polyol ester for organic ranking cycle application. And we have a complex ester, a CA500, a high viscosity polyol ester, also for high temperature heat pump application in screw and piston compressors for the R1234 ZE and for the R1336 MZZ. That means for fluorinated HFO systems. So in general, so we can recommend these type of lubricants for these type of application with good result. With regard to chemical stability, with regard to thermal stability, yeah, here we are talking about 150, 180 degrees Celsius or higher, yeah, which is an enormous thermal stress to the lubricant itself. And with these type of lubricants, we guarantee lubricity and we guarantee thermal stability as well. So, I think more or less this is a description of the properties. So in this case, CE 500 is 500 centistokes at 40 degrees Celsius. It's like a gear oil from the thickness. But now you can imagine the dilution of the refrigerant itself will decrease the viscosity, and in addition, the temperature itself will decrease as well, the lubricity and the film thickness. So that's why we selected these relative high viscosities and this relative special chemical structure to avoid reduction of viscosity, to avoid wear in the compressor, especially in the piston, in the screws, or in the bearings. And on the other hand, for fluorinated systems, HFO refrigerants, we recommend polyol ester 320, which is also in use in different systems for organic ranking applications. So, at the end, I want to mention CO2. CO2, we have developed since, I think, 20 years, have developed and introducing the Reniso C grades for different type of application, for subcritical and transcritical application, for compressors, for piston, reciprocating piston, but also for screw compressor application as well. It was well introduced. It's not only the system, it's not only the polyol ester, it's for sure the polyol ester in combination with the additives, special additives which are under very high pressure and high temperature. That means 180 degrees Celsius for this application, very stable in the oil, and which prevent the compressor from wear under these severe conditions in CO2 applications. And as I think this is one of our highlights, we have also developed a special type of lubricant, Reniso ACC HV, for hermetic compressor systems in the e-mobility with the German automotive industry. These are sealed systems, hermetic systems. These are special type of compressors which are sealed with our system and which is well introduced for CO2 systems in e-cars, Volkswagen Group, Daimler, and others are working with this oil since now many years. And this is a real success. We have a patented formulation. It's not only the base oil, it's here as well the additives in cooperation with the base oil, which prevent the system, the hermetic sealed compressor, from wear, and which guarantee lifetime expectation as well. At the end, I want to mention that we are also present here in the Tilventa. We have a booth in the Hall 7. Please, if you have interest, have a look to Fuchs, and we can talk about systems and solutions from Fuchs with the Reniso refrigeration oils. Thank you very much for your interest.